These essential wires are specifically used for the primary beam probe and the secondary angle beam probe. These are exactly the ones located here. For these ones, we won't touch them for now. We will be scanning with this kind of probe. Not scanning, but measuring thickness. Double crystal. As for the single crystal, we will use the cloud and the single one, but for now we won't use the single crystal probe. So what makes them different here is that one signal to this and comes back. Here, from one side, it hits the other side and comes back. So what we do is insert it like this.
So, does the client order this, or can we choose what we need ourselves?
The probe.
For
They send us. So, to measure thickness, this is a standard probe, but they're kind of universal, and I don't really like them. In some cases, they just don't do their job, but usually they only send us this, and we work with it. Sometimes there are specific pipes. For example, if the thickness is 3 millimeters or 4 millimeters, you need a different one. As for the probe, it's best to use either a 2-inch pipe or a 3-inch one. The diameter should already be set. If it's smaller, that's fine, we insert it. Right here, it doesn't matter if the red is down or the black is down, it makes no difference. We turn it on here, here's the power button, press it for 2 seconds. Release it, and then it automatically turns on. To measure the precise thickness, we will utilize this measuring block. If they send us a K2 or a B2, a block like this one, then we would always ask to have a step block, and you can easily measure it. It is precisely 12.5 millimeters, but it is always much more preferable to have a proper block. You can calibrate it, but usually calibration is done. Single crystal. We won't go into that in detail. We need to carefully determine if we're accurately measuring. We already know the precise nominal value, as it is clearly written and documented in all of our official documents. If it's a 20 millimeter block, we select 20 millimeter. If it's 25, then 25. If it's exactly 10, then we will carefully take 10 or 5 or whatever precise measurement is clearly written. Usually, I meticulously use a reliable ruler to accurately measure it for optimal precision and accuracy. Each of them. Here you have 20 millimeters, 15, 10, 5, and so on. But we don't measure this one because this sample isn't designed for that. This sample is designed for up to about 5 millimeters. You can do 4, but it's already difficult. 3 millimeters.
and more than that, right?
Yes, from 5 and up. It's very hard to measure anything below 5 with it.
Question. Let's say if here the sample is for 20, 15, 10, but what if, for example, the pipe is 16 millimeters thick?
Then we take it. If it's 16, we take between 15 and 20. We take 2, we set up the calculation method. And the closest one, in this particular scenario, is 22 millimeters. If the original measurement is 9 millimeters, then we typically take into consideration a measurement of 10, because the pipe material inevitably gets worn down over time. If the nominal or initial thickness is 9 millimeters and there is significant corrosion present, then its actual thickness will already be reduced to 8 millimeters. Yes, 8 or even 7. So we will take the two numbers, 5 and 10.
Ultrasound is mainly used for pipes, right? Pipes are measured in
most cases it's pipes, but sometimes yes. Mostly because almost everything is about pipes. There are caissons, pipes, and things like that. It's very rare when it's plate. Sometimes it's plate, but that's very rare. Very rare. And
the metal doesn't matter either. Is there any difference in which metal you check?
we usually check carbon steel, so the calibration block is carbon steel. If it's stainless steel, we need to have a stainless steel calibration block.
And everything else is the same? Yes, also.
The same. This device, the UT device, it doesn't measure thickness. Everyone thinks it measures thickness. It doesn't measure thickness. This device measures only speed, only the time it takes to travel through the metal and return. It doesn't measure thickness. We simulate the thickness, for example, that it's 20, and you show
Input for the device.
we understand that for this amount of time, but it will be a thickness of 20. But if we have paint, then the time for the thickness will change. That's why it's very important to measure with double crystal, preferably without paint. Measuring with paint is considered incorrect, but we do it because it's easier. With paint, you should use the single probe to measure. That's the most correct option. That's why they send it. But for now, we won't be doing that because the signal is much worse. And that's why we usually don't. But the most interesting thing here is that you can set it to a specific thickness, for example, to 15. And everywhere with paint, it will show the same value. So the paint. Yes, it definitely subtracts it, but this particular measurement, this is only an approximate calculation because here the potential error becomes quite significant if we were to change it in any way, and that's precisely why it's commonly used, because it accurately measures without any paint present on the surface. There are 4 distinct crystal probes, not just 2, but indeed 4, which are designed to measure both the paint layers and the underlying substrate material. Yes, that's a truly cool, a very impressive probe, but unfortunately they never actually send them out, and for that you would require an additional specialized program, which is known to be very expensive, so consequently they're not widely used. So let's just say, for now, what we typically do is we take a small amount of gel, specifically 15 and then 10. Yes, usually the standard is 15 and 10. We measure approximately these thicknesses. Press firmly, then press the center and hold. The entire menu appears. So what do we need here? Here, usually, for saving, this is the first one. This is the file, if I'm not mistaken, file management. Here we usually use, you can enter a name and save it. I have a video there on how to save. Let's switch further. We go here, thickness. So probe. Probe angle is off, 0. That is, we have probes at 45, 60, and 70 degrees. We turn them off. And here, you need to specify that this is not a pipe, not round, it's flat. You can specify the pipe diameter, yes. Usually we select flat. And
Even for a pipe, that is, when we calibrate, we select flat, right?
for a pipe, it won't change much, really won't change much, because it's made for what? Because the probe moves. When it's on a pipe, it moves. But usually the pipes are large. If the pipe is small, we take the wedge and the probe and set the flag further. Reading. USSR. This is very important. S, and this first signal which fires,
Inside goes when
it reaches here, it comes back. It gets divided by 2, and as a result, the distance, it shows us the distance.
from this. It means that SA is forward and back.
Yes, and it divides by 2, and it shows us. Here it will show 10.
10.
Forward and back. Yes, it divides by 2, and it will show 10. The program divides it automatically. SB is already the second signal, which goes from the top, reflects, and comes back. Why SA SB? Because if the paint is applied, it doesn't go through the paint. It reaches the paint, bounces back, and then we catch the second signal. The first signal will be long, because with the paint it's 2 times shorter, and SB calculates 1 and 2. And so it turns out to be without paint. It's quite clear, isn't it? Okay, if there's a layer of paint on the very top surface, the signal passes completely through that paint, then it goes directly through the underlying metal, subsequently comes back, and finally rises all the way to the top again. And it only reaches the paint. It doesn't go through the paint, it reaches the paint and comes back, and then we catch it. And that's why we can... But you don't need to overthink it, it's just clear. The first, the second signal, and this difference, that's exactly
What we need.
without paint. Or if you clean the surface as best as possible, then you'll get the most accurate result without paint. That's it. We should have SA, SB, SBA set. Next, the DAC curve is for angle probes. For scanning the entire weld, it then subsequently turned. So, what exactly are we doing here, in this particular situation, at this precise moment? Orientation of the left hand, right hand. Joystick is on. Brightness is set to 10. Light blue. That is, you can change it as well. This is the grid, the diagram. Basically, we set the language millimeters. We just set it up, and we can see both instant branding and configuration 2. Here it's important to set up function 1 and function 2. What the upper and lower joysticks and these buttons are responsible for. And dB, meaning that this will be the precise sensitivity setting for optimal performance. Next, automatically set to 80. That is, it calibrates to 80% of the monitor. And recall dataset. We definitely need recall dataset. So, we press the lower button and we go back. And all the saved menu settings we had can be recalled. At some point we made the settings and saved them. And they are saved. They are saved to a memory stick. You can save them there or you can save them in the device itself. And you can transfer them via the memory stick, here it is, to a computer, and next time you come, just load them back in. And all the settings will already be there. That's it. You just need to tweak a few minor things. I'll show you what later. Or you can do it yourself. Set all of this manually. Key up, positive, positive. In other words, both should be set to positive, exactly the same. This,
Always and no matter what it takes.
it can't be negative, only positive, so we set it to positive. Next, this is the crucial difference, how incredibly sensitive it will be, and specifically, how much will precisely change each interval, 0.2 and 0.6. The smaller it is, the easier and more precise it will be to adjust.
The smaller the interval, right?
Yes, but if the interval is every 10, it'll just jump around. We still need to reduce it so that the adjustments are smaller. So, and here, pulses spike, we leave everything else the same, then we move on to configuration 3. The joystick works, so we scroll down, and here we can then, configuration 3 is envelope red. Basically, we leave it as is. Configuration 4 isn't that important for us here either. We've set everything else, and now we exit back to the file and press the center button again. After pressing the center, we're back in the main menu. That's all we work with for now, that's the most important part. Here, as I mentioned, with A it shows CA, CB, and the difference without paint. The first signal, the second signal, and without paint, the second signal will be longer. Because it goes back and forth, while the first ones just go back and forth. Now we set it to, you can set it to 15, and then down below, you can clearly see that we now have 0, 10, and 15 displayed. It immediately and accurately shows the value of 15. Here it matches up, it is 15, exactly 15.
That's just it.
That at the bottom it's 15 millimeters, it even shows it at the bottom. And it already shows us that the device is set to 14.8. It needs to be calibrated. And
it needs to be adjusted to 15, right?
It needs to be adjusted to 15. Now let's see what, without paint, it comes out to 2643. That's incorrect, it's showing the wrong value because we need the first gate to be green, specifically green, not blue. You mustn't mix them up. Gate 1 should hit the first signal, gate 2 should hit the second signal, then it will display correctly for us.
Ours is offset. That's what it turns out to be, yes?
If we carefully move the entire range up to the gate, gently bringing it up to the gate from below, here it is, clearly visible and glowing a vibrant green. If we then proceed to remove the gate start, moving it completely away from the signal, we effectively take it away from its original position. We've removed the signal and now it will
16, show.
There, we've removed it. Now it's showing 29. That's not what we need. We need this to be the first signal. We see the first signal and set it to the first signal. Because we can just as easily set this gate here. Here it's showing us 44. That's incorrect. To make it display correctly, we need to return it to the first signal. 40%. Well, here it automatically sets to 40%. Or manually, the peak should be set and the sensitivity should be 80% of the screen.
We set that as well.
Here, 8. If we set the sensitivity so it's 80% of the screen, it will show us, but that means it's incorrect. Right now the calibration is showing us 14.0, 14.8. It should. Next, the second one should be on the second, and the second will be blue. Here, gate B. We go up and return it to this signal. This way you can move quickly with the joysticks, and like this, just a bit slower.
And it should be in the center, right?
Yes, in the center more or less. And we can make it a bit wider. So we make Y wider, and then center it again, roughly like this. Next, our peak is set, and here we also make the gate width a bit wider. Move it a little toward the center. That's it. Now
In front, this is the first one, a green.
Up to the green gate. Here at the bottom it says green gate on the first signal, blue on the second. Now everything is set correctly. So it will show us 14.9 to 15 millimeters without paint, but we need to check the SA. It should be 15, which means our calibration is off, so we're going to set the SA correctly. Alright, moving on. We go back to the menu, go to gateway, and then back to range. What is range? Range is the distance that we will see on the screen. So if we're calibrating at 15 millimeters, the distance should always be such that we always see 3 signals. 3 signals. And they are bigger, smaller, and smaller. There could be 4 or 5. But you should see at least 3 signals. Right now we see 5, which is fine. You can change the range. What is range? It's our scale. The scale is 70. Right now we see a thickness of 74 millimeters. Here is 60. Now we only see 2 signals at 30 millimeters. We have a calibration block at 15. Here is 15, here is 30. We can't see any further. We should be able to see the third signal. To see the third signal, we reduce the scale. Let's adjust the scale.
So, before this was considered the scale, right?
Yes, the scale. Now we see 40 millimeters. So it's scanning now. It goes up, down, up, down, up, down, and here. So this is 15 millimeters. And here it says, look, 60 millimeters. Now we'll scan it. It's scanning 60 millimeters. So it comes back once, comes back twice, comes back 3 times. Each time the returning signal decreases in strength. It fades. It can't. It keeps fading. That's why we see the first one strong and the second one weaker. And then even weaker after that. And we measure by the first and second signals, so earlier we set it to about 63 signals. That's fine. Next, and the probe delay for this sample, move the probe closer. S. Everything is visible. Yes, that's right. For this sample, you need to set about 9 probe delays, approximately 888, 994, 920. The speed of the metal is correct. It's about, right now it's 5,966, 5,960, somewhere around the standard. Sometimes it's 6,010, for example, roughly around 6,000.
Can it vary, or is it only 6,010 or 5,960?
It will vary depending on the calibration of the unit. So we have different steel, different types of steel, different speeds. That is, for carbon steel, it's 5.0, 5,960. That's what's generally considered. When I calibrate, sometimes it reaches Here it's important to set how many megahertz the probe is. Here it says 4 kilohertz, not 4 megahertz. Here we carefully set it to 4. If for some reason it is not currently 4, we then change it to 5. Usually the standard settings are 5 or 10, so we have set it to 44. Here is the full wave setting, and this is quite important. If it is single, here we must switch it off. So it turns out to be a single 1 crystal probe. This single should be set to dual op. If dual is on, then it's double, meaning a double crystal. Double? Yes. So here it's 0. DAC is again for these probes. We're not dealing with that for now.
And what are these probes for?
To scan the weld.
Ah, for the weld.
And this is for thickness measurement. The thickness probes are angled so they shoot at an angle, while this one only shoots straight down at 90 degrees.
This is something that might be relevant for my work, maybe something we...
For now, let's not touch that. Maybe we shouldn't touch it at all. Autocal is for calibration. Auto calibration. I don't use it, it's inconvenient for me. There's a detailed tutorial available on YouTube where I thoroughly demonstrate how to effectively utilize AutoCal. However, personally, I don't particularly like it, and I much prefer employing an alternative method. Additionally, there exists another distinct calibration method, which we are now going to proceed and try out together. So here's what we do. We go to range, the very first column. And here, we do it manually. We adjust it so that we get 15, meaning we change the probe delay. Now we'll see how this works. For example, if we set the probe delay to 15, that's manual. Now let's look in the other direction. Let's see how it works. Will this work or not? What do we need? Is it the first one or this one? Two values. We need to change the probe delay and adjust the velocity and the speed. So we've set it to 15. Next, we go to velocity and change the speed. Set the speed so that we get 15 to 30 here. So there, 15 to 30 minutes. And then
You can slightly
reduce this idea a bit. 15.2, right? Now we're reducing it. Actually, if we're working with velocity here, we set it to 30. We just go right here now. Here, 15, we take the velocity, set it to 30 here, right? Here it is exactly 12, so we have 12 right here, then 30 over here, followed by 15, and finally 1. In the opposite direction, we now have 15, 30, which is absolutely perfect. There, it is clearly showing us a value of 499, and that is perfectly fine.
there could be an error, right?
An error, yes, 0.1 millimeter. It's possible. So this is already 15, which means it's 100. But we can set it. Now it's 15. 15.01. Well, you can play around with it, of course. Here, everywhere, it's 15, 30, 15. That's it. But it all depends on the force we apply. The pressure, we need to press the same way we do when scanning. If we press too hard, it changes a little. Not by much, but it does change. And it also depends on the gel. So with each gel, we need to calibrate. And every time we go for a coffee break and come back, or every half hour to an hour, we check again. Or whenever we have doubts, we double check. We have the calibration block attached. It's tied to our pocket. And we just make sure that it's 15 here. Here, we took 15 here.
We measured here. And what if we move to another part?
Now we will quickly switch to the number 10. Now it's going to change. There you go. What do we see? Most importantly, we see 10, 30, 19. It's showing some nonsense. To stop it from showing nonsense, we need to move the gates. So we go back to the gate. We move the gate so that it's roughly centered. And we move gate B as well, so that it's also on the second signal. Now it's showing us our current calibration, which is 10.3, and then we have 9.95, so those are our precise measurements.
And here too, basically, you can play around with it like before, or just leave it as is.
Yeah, if we start increasing it here, it starts to get messed up over there.
Oh, the previous calibrations, right?
Yes.
So in that case, you just need to stay here. Just run tests on the second signal. Still 9.
Yeah, you can do that here. If we're working closer to 10, say if we have 12, then we adjust it closer to 10. So we take that. But we double check ourselves at 10 and at 15, whichever is closer. So we have 12. We're at 10 because the offset always goes in the lower direction. What do? We go back to range. And here we can clearly see that there are indeed 3 distinct signals, perhaps even more than just 3, which is actually quite good, representing a significant 80% of the entire monitor's display. And now, at this point, we will simply take and adjust it closer to 10.
But then the other one will get upset, right?
Yes, the other one will get upset, might cry, but it's no big deal.
The ball won't drown in the river.
Yeah, that's right. And now we look, well, 1502. So now if we move it, we'll see that it hasn't changed much. We've kind of adjusted it. Alright, now we'll move the GTP. Here it's showing 1505. Well, if we set the 10s to 12, then we calibrate it closer to that value. And now we're switching to, here, we're moving the GITB. You always need to make sure that the peak doesn't, there's a peak here and a peak there, so it doesn't jump over. You need to keep an eye on that too. Alright, we're moving it now. What do we see? We see 10.998. Everything is fine. We can start scanning. Let's say we don't know the thickness of the metal, so we take a measurement on the metal.
But this is a different metal.
Yes, but we can certainly check, we can thoroughly look at it right now and carefully see precisely what it clearly shows us. It gives a very poor reading because it's about 3 millimeters thick. We won't be able to measure it because this probe won't work. This probe gives completely nonsense readings. You can see that, right?
No.
It doesn't matter that it's galvanized. 3 millimeters. If we take, say,
A weld bead
a drip from welding,
through the paint.
we measure through the paint. What does it show? It shows us the correct model. Now we need to reduce the sensitivity to 80%. That's important. The first signal is at 80% like this. And here it shows us 80% specifically right here. If we set the percentage like this. And now what do we see? We see that after the paint it's 9.94. So that's basically 10. Now we move it over here. Here it's a perfect 10. It was exactly 10. Exactly 10. So this is metal, a 10. We measure it with everything. If there's rust, it's very hard to measure through the rust. That's why we need to clean it off. But let's check now. Here it should read through the rust. It will even be counted as paint. Very weak signal. Very weak, so we're looking for a spot. Basically, we need to clean it off. Right now, we're measuring through the rust, and the signal is very weak, so we need to boost it. We increase it to approximately 80%, and it displays us the value of 1043, 1028, precisely the same 10 as before. But if we meticulously clean it, specifically the area around 8993, if we thoroughly clean it, the resulting value will undoubtedly be much closer to the ideal, perfect state. That's precisely why it's incredibly important to consistently keep cleaning and maintaining it. If we're dealing with a very thick, substantial piece of metal, like the one right here for instance, let's carefully go down to the deck now and examine it more closely.